Hey physics class, how's it going? We have our last new content for this whole year. The last couple weeks will be a project that I'll talk about later, but let's get to the content. So we have gravitation and orbits. So gravitation meaning basically like the gravitational field or gravitational force from a large object such as Earth or Sun or something like that. And then orbits is again basically our circular path. So this is going to tie in a decent amount to our circular motion that we talked about last week, and all of those formulas from our circular motion are going to tie into this week as well. Okay, but we have some new formulas and some new constants that I want to talk about this week. What do I mean by a constant? Like the mass of Earth, the radius from the middle of Earth to the outside, like to where we stand, where I am right now, as well as the thing called this gravitational constant. It's basically just the ratio and the connection between the mass and how much force we kind of have. But let's talk about the one big formula that's going to be added into this week. Basically, there's only one formula that's new this week, and that's this one up here, okay? The force of gravity, okay? And that's kind of basically the same as, like, if I were to go, like, how do I get force of gravity equals, like, force of gravity equals mass times gravity. Well, that works. This is the bigger one, like, well, now we use that, like, force mg, like m times g, because we're always the same distance away. We're on Earth. If we get satellites going and moons going and stuff, there's a much bigger difference. And so here's our formula. Force of gravity equals our gravitational constant. I'll talk about this in a second. Okay, this is a constant. It's given to you. It's kind of like mu. Okay, but a little different. But it's a constant, same like that. Gravitational constant. Okay, there's two m's. There's a big M and a little m. Those are both masses. I just like to put one as a big M and one as a little m because I don't like to have like M1, M2 right beside each other. So there's just two masses. We're talking about like the gravitational pull between two objects. So like what's the gravitational pull between Earth and me? I have a mass, Earth has a mass. So there's our two masses, okay? We're talking about two objects that have a gravitational pull on each other, like Earth and the Sun or Earth and the Moon, that kind of stuff. So there's two masses. And then the radius, okay, basically the distance between those two objects, okay, is the radius that we're looking at here. So big G, gravitational constant squared, m times m on top, and then radius squared on the bottom. Let's look at some constants we're going to be using this week. The gravitational constant, 6.67 times 10 to the negative 11. The one annoying thing I would say about this unit is that it comes with a lot of like times 10 to the 11, so a lot of scientific notation. Okay, and trying to remember how to do scientific notation can be hopefully a quick reminder, but can be a little annoying sometimes to just kind of get back in the motion. I'm going to do a couple examples right now here, just so that we have a little reminder, but we'll go through that in a second. The mass of the Earth, 6 times 10 to the 24. That's 6 with 24 zeros after it. So you're going to really want to use sign notation because I don't want you to have to write down 6 with 24 zeros after it. That's a lot. And then the radius. So the radius between me, where I stand right now, and the middle of Earth is 6.38 times 10 to the 6 meters. Meters. Guess I should put meters, kilograms here. Okay? So meters. I will say one kind of thing. I'll remind you actually when we get to that question. No big deal. So there's kind of our new formula. There's our constants. This is going to tie in, again, a lot to our circular motion because basically, I have force of gravity here. I like to add this in here. Force centripetal also equals force of gravity. If we think of Earth, and we think of the Moon, okay, traveling in a circular motion around the Earth, again, what is keeping this Moon in its circular orbit? Because, again, that is a circular motion. There needs to be some kind of acceleration and force that is always pulled inwards, okay? Because if not, if this Earth magically disappeared, this thing would be going straight from, like, there'd be no curve to it, okay? Because it's in a circular motion, there needs to be a force centripetal that is keeping it in that motion, all right? And that force of gravity, the force of gravitation, is what keeps these things in that circular motion. So when we look at over here, okay, we have our force equals mass times acceleration. This is force circular, that is acceleration circular. A lot of the times, almost 99% of the time when we're talking about what is keeping the force of all these things in orbit, it is the force of gravitation between these two objects. Okay? So there's my little intro of this kind of intro of gravitation. I want to do one little intro about scientific notation. Okay, let's say I want to do something like this. Okay, I'm going to take a very standard question. Let's say we're going to try and find the force of gravity between Earth and a 1 kilogram object. So I have a 1 kilogram weight. That way I don't have to times it by it. Let's find, and it's on Earth. What is the actual, what's the actual force going to be? So let's try and do that. We have our gravitational constant, 6.67 times 10 to the negative 11. Okay. I'm going to have my two masses. Now, big mass, force of gravity, sorry, mass of Earth, 6 times 10 to the 24 times 1. It's a 1 kilogram object. Okay. And then divided by the radius squared. So radius of Earth, 6.38 to the power of 6, brackets, brackets, squared. Okay, there's a lot of scientific notation happening here, so it can be a little overwhelming sometimes. All right, first off, bed mass, what I have to do this bracket first. So how do I do a power that has a scientific notation? Well, you're going to multiply this number by itself. Okay, so 6.38 times 6.38, and then you're just going to take 6 multiplied by 2. Okay, when you have a power with a power, you multiply. So I'm going to get at the bottom here. So I'm going to still use 6.67 times 10 to the negative 11. Still going to times by 1, so we'll ignore that. 6 times 10 to the 24. When I go with 6.38 times 6.38, 6.38 times 6.38, I get 40.7. 40.7, and then I'm just going to times this by 2. So times 10 to the power of 12. Okay, this should be times 10 to the power of 12. Not 6 to the power of 6, but 6 times 10 to the power of 12. Sorry. Okay, so now I have that. When I have this dividing, okay, just divide the numbers, and then when you're dividing our sign of notation, when you're dividing powers, you're going to subtract. So 24 subtract 12. So let's go. 6 divided by 40.7. I get 0.14. Okay? So this is going to turn into 6.67 times 10 to the negative 11. Multiplied by 0.147 times 10 to the, right now, 12. Okay, I went 24 minus 12, so now I have a power of 12. Okay, and lastly, I'm going to make sure I multiply these. Okay, when I multiply powers, you are going to add. You're going to add the actual sign of notation. So what is 6.67 times 0.147? I get 0.98. 0.98 times 10 times 10 to the 11. 1. Okay? Times 10 to the 1. Okay, and if I want this answer, like again, times 10 to the 1 means I'm just going to multiply by 10, which gives me 9.8. Hey! And if you should be able to figure it, if there's a 1 kilogram mass, what's the actual gravitational? If I just go back to my very simple m times g, I get 9.8. So 9.8. But I wanted to show this for the reason of like, what do I do? So when you have a squared, just multiply the power like by 2, and then make sure you square this still. When you're dividing, you minus the actual powers, and when you're multiplying, you add the actual powers. Okay? So here's my little intro. Hope that makes sense. I'm going to go through some practice questions in my next video. Thanks, class.